Okay, hi everyone. So today we are going to continue working on what we learned in the previous video. We're going to still talk about how to factor trinomials. So this is part 2 of factoring trinomials. And in this video, we're going to take a look at some other cases. So we're just going to jump right in. So in the previous video, we factored trinomials where everything was positive. So the first term was positive, the second term was positive, and the third term was positive. But you'll see in this case, that's not true, right? This last term is a negative. So that's what this video is going to focus on. We're going to look at what happens when we have negatives. So we want to think about this the same way that we did in the previous video. Remember that the whole goal is to figure out factors of C, which is that last number, factors of C that will add up to equal B, which is the middle part, and multiply to equal C. So we're trying to figure out factors of 21. So let's go ahead and start with that. Let's start with 21 here. Now, technically, that is a negative 21, which means in order to end up with a negative, one of my factors has to be negative, right? That's how you end up with a negative number when you multiply that. Now we'll deal with that in just a second. So first, let's just list all the factors of 21. So 1 times 21, we'll deal with the negative in a second. I'm just going to list the factors for now. 1 times 21 or 3 times 7, and that would be it, right? Now remember, we have to make sure that these add up to this middle term here. So I need them to add up to 4. Well, if I just add these the way that they are, it's not going to equal 4, right? 1 plus 21, well, that equals 22, and 3 plus 7 equals 10. However, if I make one of them negative, then we could add up to 4. And we have to make one negative anyway because I need it to multiply to a negative 21. Now, if you think about the first pair of factors, that's not going to work either way, because if you had the 1 as a negative, well, negative 1 plus 21 is 20. And if you did it the other way around, so 1 plus negative 21, well, that's negative 20. So that's not going to work. We want it to add up to 4. But if you look at that second pair of factors, so this one doesn't work. If we look at that second one, in order to make that add up to a positive 4, I could put a negative on the 3, right? Negative 3 plus 7, well, that adds up to positive 4, and that's what we want. So we know that our factors are going to be negative 3 and positive 7. So now we're going to go ahead and fill in our binomials just like we were doing in the other video. So we want the 3 to be negative though. So instead of x plus 3, I'm going to write x minus 3. And then the 7 can be positive, so x plus 7. And there we go, that would be completely factored. So we could write the factors the other way around. So these two factors, it does not matter which order you put them. So I could put x plus 7 and then x minus 3. I could write it this way if I wanted to. It doesn't matter. As long as the negative is on the correct number, right? That negative has to be on the 3. Now remember, we could always double check this by multiplying. So we're going to do it for this first one. We won't do it for the rest of them in the video, but just to remind you, if you wanted to check your answer, just take your binomials and multiply them. So x times x, that's x squared. X times negative 3, that's negative 3x. 7 times x, that's positive 7x. And then 7 times negative 3 is negative 21. And then if you combine the middle terms, just like we normally would do, negative 3x plus 7x is positive 4x. And if you bring down everything else, this does look like it started with. So if you look up here, x squared plus 4x minus 21, x squared plus 4x minus 21. So we did it correctly. All right, so let's look at some more examples. So in this case, now the negative is on the middle term. So we're going to think of this the same way. We're always going to do these the same exact way, but you'll see that the negatives and positives are a little different depending on how it's set up. So the negative is on the middle term. Well, let's start this the same way we always do. We always start with this last number, which is a positive 12, and I want to figure out what multiplies to equal 12. And keep in mind, I need it to be positive. So 1 times 12, 2 times 6, 3 times 4. And that's it, right? Now, I need it to be positive, but if I keep both of these numbers as positives, they are not going to add up to a -8, right? If I add these numbers up the way they are, it's not going to work. Now, we know right away that this first set of numbers is not going to work either way, because if you add those, you would get 13. If you subtract them, if you made one of them negative, you would get either 11 or -11, which is not what we want. We want it to equal -8. So that one's not going to work. Now this one, if I add them up the way they are, that's going to be +8, which is not what I want. But in order to make them to equal -8, I could make both of them be negative, right? -2 plus -6 is -8. And remember, two negatives, when you multiply them, it does equal a positive. So this fulfills both of our requirements. We have a +12 if you multiply, and we have a -8 if you add. So I want to make sure that both of these numbers here are negative numbers. So when I fill in my factors, so let's go ahead and write in our binomials, I want both of them to be negative. So x minus 2 and x minus 6. Okay, so let's take a look at when both of the two numbers at the end are negative. So the middle term and the last term, these are both negative. So let's go ahead and start. Now this is an easy one to factor, right? Because -3, it only has one thing that would work, 1 times 3. Now I need this to add up to a -2. So you got to think about which one of these two numbers would have to be negative if I want them to add to a -2. And the answer would, of course, be the 3, right? I need the 3 to be negative because 1 plus -3 is -2. If you made the 1 negative, then it would be equal to +2, which is not what we want. So we're going to go ahead and fill in our factors here. So again, we're making sure that the 3 is negative and the 1 is positive. So a plus 1 and a minus 3. Okay, so now we're going to take a look at some mixed examples. So they're all mixed up and they're all different cases, and you just want to be careful. We're going to follow the same process for every single one of these problems. So let's go ahead and get started. Okay, in the first example, the last number, which is C, remember we always start with C. The last number is -16. So I like to just list out the factors first, and then I figure out where the negative is supposed to be. So let's go ahead and list out the factors. 1 times 16, 2 times 8, and 4 times 4. Okay, now I need to make sure that these will add to 6. And remember, there can be negatives, so I need to make sure that they add up to 6 or they somehow kind of subtract to 6 if I put a negative on there. All right, so I know the first one's not going to work because 1 plus 16 is 17, and if you subtract those, you'd get some version of 15. This 2 and 8, that would work, right? If I want those to equal 6, I would have to make the 2 be negative. -2 plus 8 equals +6. So I've figured out my factors. I know that the 2 is going to be negative and the 8 is going to be positive. So let's go ahead and fill those in. I'm going to use the letter A since that's what this problem says. So I'm going to do A minus 2 and A plus 8. All right, so for the next one, well, those are both positive, which is great. This is just like the video we did the other day. So those are both positive. Let's just go ahead and figure out the factors. To get to 40, we could do 1 times 40, 2 times 20, 4 times 10. There's quite a few factors of 40, right? So if you just keep thinking about it. Now, I do want to mention, as you're listing out these factors, you're going to get to a point eventually where you might not have to actually write a physical list like this. If you can just figure out in your head which numbers will multiply to 40 and add up to 13, then there's no need to make this list. But it is helpful if you are not able to figure out your factors. Okay, so what else multiplies to 40? 5 times 8, and it looks like we can stop there, right? Because if you add 5 and 8, well, that's going to get you to 13. So let's go ahead and figure out our factors here. It would be y plus 5 and y plus 8. All right, so the next one. Now remember, there is actually a number here, right? That's actually like a -1. So anytime there's no coefficient, there is a 1 right there. So we're trying to find factors of -30 that will add up to -1. So let's list out the factors of 30. So 1 times 30, 2 times 15, 3 times 10, 5 times 6. And 5 and 6 would work, right? Some combination of 5 and 6 would work because I know that this is going to get me to a 1 or -1 because I could subtract them. And I need the negative. Remember, I want it to equal -1. So I need the negative to be on the 6 because that's how I could make this equal -1. So -6 plus 5, well, that would give me -1. So here we go. N plus 5 and minus 6. All right, so let's take a look at this next one. So we've got -72. Now these are both negative. So let's see, -72. What multiplies to equal 72? Okay, there's actually quite a few things that multiply to 72. So I'm gonna go ahead and start listing them. Now, if you don't know how to find factors in your head like I'm doing, like let's say you just don't know all of your factors of 72, you can use a calculator. You can just start dividing 72 by things that you think will go into it, and you can start making your list that way. Your list doesn't have to go in order. If you want to just try to figure out factors just by guessing and checking, that's fine too. So let's go ahead and start listing them. I'm just going to start listing them based on the ones I know. So 1 times 72, 2 goes into 72. I know 2 goes into 72 36 times. 3 also goes into 72. 3 times 24, 4 times 18, 6 times 12, 9 times 8. Now, I'm actually going to stop here. I think that's all of them anyway, but remember, we're trying to get to a -14. Once you find a pair of numbers that will somehow get you to 14, you can stop. And I see a pair of numbers in this list that will do that. So if you look at 4 and 18, well, that would get me to -14, right? The negative would have to be on the 18. That's how I could get to a -14. So I want -18 and I want +4. So let's go ahead and write these out. X plus 4 and x minus 18. All right, so in the next one, that's a +48. +48, but the middle number is negative. So if you remember in the last, when we did one like this before, the only way that I can end up with a positive number when I multiply and a negative number when I add is if both of my factors are negative. So that's what's going to happen here. Let's go ahead and start listing the factors though. So 48, 1 times 48, 2 times 24, 3 times 16, 4 times 12, 6 times 8. Now we could stop because remember we're trying to get to -16 and I see a set of numbers that would get me to -16. So these two right here, 4 and 12, if you put those together, that equals 16, right? Now remember, I want this to equal a -16, so I need both of these to be negative. So remember that two negatives, when you multiply two negatives, that equals a positive. So -4 times -12, that equals +48, which is perfect. And if I add these two negatives, that equals -16, which is exactly what we want. So that would be our factors, W minus 4 and W minus 12. All right, and then the last example. The last example, everything is positive, which is really nice. So this is just like the other video that we did. Everything's positive. So factors of 42. Now you might not need to make a list. Can you think of factors of 42 that would get you to 13? I'm just going to let you think about that for a minute. Think about factors of 42 that would get you to 13. And you probably figured it out. It's actually the factors of 42 that most people think of first. 6 times 7, right? 6 times 7 equals 42. And if you add 6 plus 7, that equals 13. So those would be our two factors, k plus 6 and k plus 7. Okay, and that is it. Now, one thing I just want to remind you, you can always check your answers just by multiplying. So I'm not going to go through that because we did it in the beginning, but for example, if you're working on a problem and the factors were kind of strange, this one was kind of strange, right? If you wanted to check your answers for these, all you would have to do is multiply the binomials. So just like normal, when you take the first term and you distribute it to both terms over here, and then same thing with the 4, you could just multiply these binomials, and as long as you ended up with the trinomial that you started with, you know you did it correctly. So just keep that in mind. All right, that's it for today's video, guys. See ya.